So for system overview, Tetris Lab is a browser-based Tetris game built with HTML, CSS, and JavaScript. For reference, this is to show our source codes for, so this is for the HTML, this is for JavaScript, and this one is for CSS. So our system supports movement, rotation, collision detection, hold piece, undo, scoring, and line clearing.
These are the list of algorithms we use in our software application. Random piece generation algorithm or random piece. This algorithm randomly selects and generates a game piece to appear on the board, ensuring variety and unpredictability during play games. Detection algorithm or collide. This algorithm checks whether a game piece touches other blocks or the boundaries of the game area to prevent invalid movements or placements. Matrix rotation algorithm or rotate. This algorithm rotates the game piece by changing the arrangement of its matrix values, allowing players to adjust the piece orientations. Line clearing algorithm or sweep lines. This algorithm predicts and moves completely filled horizontal lines from the board, then shifts the remaining blocks downward and update the score. Last, undo mechanism using a stock or action stock. This algorithm stores players in a stock data structure, allowing the game to restore the last move when the undo features is used.
So, in this slide, it explains the data structures used in game system. So, the first one is the 2D array. This is used to store the game board. Each cell in the matrix can represent any empty space or a filled block, so it is perfect for placing determinate shapes on the grid. So the next one is the stack. This is stores previous game state, which is used to undo feature. When the player makes a move, the current state be saved so it can be restored later. So the next one is the objects. These store important information about the game, such as the player's positions, score, level, and the current game status. Objects group related data together in one place. So the last one is the arrays. This store list of things like colors, pieces, or save snapshots. Arrays are useful when you need to keep multiple values in order. So in short, this slide is saying that different data structures are used different parts of the game. The board uses matrix, undo uses stock, game information uses objects, and the collection like pieces or colors use array. So next.
To conclude the successful implementation of this Tetris game, demonstrate how algorithms and data structure work together to create an efficient and interactive gaming experience. The algorithm used including random pieces generation, collision detection, matrix rotation, line clearing, and the undo mechanism ensures that the game functions accurately and smoothly. These algorithms handle the core gameplay mechanics that makes the game responsive and enjoyable for users. At the same time, the selected data structures such as arrays, matrices, stacks, and objects provide an organized way to store and manage game information, including the game board player data, scores, and previous states. Overall, the combination of these algorithms and data structure results in a system with low computational complexity, allowing smooth real-time performance and an enhanced user experience. This project highlights the importance of choosing appropriate algorithms and data structure in developing efficient and reliable software application. And thank you for listening.
So this is how our one second. So this is how our system looks like. Just go and start running the code. And here's the game. So you will see it here, the title of the system. It's called Tetris Lab. This system shows stocks an algorithm. This is the game itself, and you'll see the score, the level, and then these shapes are called the tetrominos. And here's the controls. These are the keyboard controls you can use to control the tetrominos and play the game. So let's say you'll resume the game and you play it. So if you click on the arrow up button, you can change the shape of the tetrominos, and if you click the space, it'll hard drop the shapes. Just a typical or the same Tetris game you, we've seen before. So how is push and pop shown in this system? So this movement I'm trying to do where I control the tetrominos, this is the push. So we're adding to stop, I mean um, we're adding tetrominos on top of the stock, and then once once we were able to complete a one single stock, it disappears and there's an additional score that shows push. So it's removing the entire row for the entire row on the game, and you score. So that's how the push and pop is shown in our system. So how is LIFO shown in this system? So when we okay, so as you can see, when playing the game, the piles like this tetrominos that we pile on top of each stock, um, we build or the pieces pile up, and once a complete line or once a mm, once the stock or a single line is stuck up, it pops. So last in, first out. So the last stock that you played is the first ones that will pop. So that's how LIFO is shown on the system.